Hello, this is Professor Dan Kernler of Elgin Community College back with another video in my statistics series. In this one, we talk about comparing two population proportions. Let's get to it. We've had a variety of videos already about hypothesis testing, where we did one where we compared the children of immigrants and the proportion that were registered to vote compared to the general population. We compared family size in the children of immigrants database to the general population. But all of these were treating that children of immigrants as a sample to the general population as a population. What if we look at students and we compare discipline rates between black students and white students? In this case, we're really comparing two populations, the population of black students and the population of white students. So we need some new information, some new machinery, if you will, about how to compare two population proportions. So let's say we have a couple of different samples. I've got one sample here, one sample here, and we want to compare the proportion that are blue. The first sample has 110 individuals. Second sample has 100. We have 41 blue in the first sample, and then 42 blue in the second. So the first sample, the sample proportion in that first sample that are blue, be 41 out of 110, that's about 37%. Second sample, 42 out of 100, that's 42%. So what we want to do is we want to compare these two proportions. Now, clearly they're different at the sample level, but the question is that difference significant? So that's what we need to do. We need to develop some theory behind the difference between two population proportions. So we have the symbols here for the difference between two population proportions, P1 minus P2. The sample would be P1 hat minus P2 hat. And this may shock you, but under certain conditions, the distribution will be approximately normal. The mean, you would expect the mean to be what the population difference is. The standard deviation, it's a little clunky. You might recognize some stuff, square root of p times 1 minus p all over n, but here there are two of them. There's some theory behind why they are added together and then the square root. We can't get into that for this particular level, but just trust us, trust me, that is the standard deviation of the difference between two sample proportions. What we need then is we need to investigate the distribution of the difference between two sample proportions. So here's the criteria. If we take simple random samples with size n1 and n2, the distribution will be approximately normal, with the mean being the difference between the actual population proportions and then this standard deviation, provided that n1 times p1 hat times 1 minus p1 hat is at least 10. Same thing for the second sample, and then both samples are less than 5% of their populations. Now, you remember our old friend, the z-score, x minus mu over sigma. Well, in this case, our x, the variable we're interested in, is the p1 hat minus p2 hat. The mean of that would be the difference between the population proportions, and then we have our standard deviation. Now, for hypothesis testing, all the ones we're going to look at, we're going to have a null hypothesis that the proportions are the same. Now, you don't have to, but we're going to do that for all the examples we're going to look at. So let's just call that P1 and P2. If we think they're the same, we'll just call those P. So then in our mean and standard deviation, we can replace all those P1s and P2s with just P, and then it simplifies to these. So that definitely helps, again, if our null hypothesis is that P1 is equal to P2. So into our Z, we replace the X with P1 hat minus P2 hat. The mean, now, if we're assuming that the proportions are the same under our null hypothesis, then the mean, the expected mean would be 0, and then we have this standard deviation. Now, we can't find a z-score there because we don't have a p. We need to figure out something for that p. Well, what we can do is we can pool together and get a total proportion. So what we would do there is we would add up the total observations in both samples and divide by the total sample size. And that's a pooled proportion. And again, you only do this if your null hypothesis is that the two proportions are the same. So then in our formula for z, those become this pooled p hat. And then we can say like, well, then z is approximately equal to this expression right here. So this is what we're going to use as our test statistic. This is going to be our test statistic when we compare two independent proportions. And the criteria here, this is provided first, The null hypothesis has to be that the proportions are equal, and then we have those same three conditions we mentioned earlier. So let's try to answer this question. Are Black students disciplined at higher rates than white students? We've investigated this before, but now we can be a little more formal. We have these counts from the data. This is a contingency table. And we're going to focus just on the Black and the white students here. Black students have a discipline rate of about 58% from this database, and then white students have a discipline rate about 24%. If you don't have this database bookmarked, I'll put the link in the description. This is from a large suburban Midwestern school district. We have discipline data, we have race or ethnicity data. The discipline here is whether or not you received at least one discipline referral within that school year. Okay, let's check these conditions. We have these four conditions. First, our null hypothesis is that the proportions are the same. Yeah, we're going to assume that they have the same discipline rates, and we're going to see, do Black students, is their discipline rate higher? All right, this first check, we can use the N and the P1 from the sample, and we get 223, so that is definitely at least 10. Similarly, for white students, you can check that, definitely at least 10. And then we're looking at, are these samples less than 5% of their respective populations? There's certainly more, like the 915 and the 4004 are certainly less than 5% of all Black students and all white students. So that is definitely the case. So yes, that condition is met. Okay, so let's do the hypothesis test. We have to define a null and alternative hypothesis. So our null hypothesis is that the two proportions are equal, and then our alternative is going to be that the proportion for the Black students is greater than the proportion for white students. For alpha level of significance, let's use our 0.05 that we typically do. The test statistic, this is going to be this kind of crazy little z. Let's talk about how to do that in StatCrunch. This is going to be under stat, proportion stats, to sample, with data. Then we'll just type in the counts. We found those from our frequency table, our contingency table, excuse me, and we'll type in our counts, make sure that the null hypothesis is that the proportions are equal, then our alternative is that it's a greater than symbol, and then we'll hit compute. Then we can see our z is really big here, 20.34. Remember, Z's are mostly, almost 100% are between -3 and 3. That's number of standard deviations. So this is really, really big. That means for our p-value, that's going to be less than 0.0001. Remember, we don't put 0 here, even though the probability is so small, it's essentially 0, but there's never truly a probability of 0. So we don't go further than 4 decimal places. Our decision then, hey, we got a super small p-value, a really large test statistic, so we are going to clearly reject the null hypothesis. So that means there is enough evidence to support the claim that the discipline rates are higher for Black students. And that should have been pretty obvious because the difference was really large to begin with. So with those sample sizes, it shouldn't be shocking that our test would show, yes, there is a statistically significant difference. Now, I always want to mention when we study this, this is not an experiment. So we don't know what caused that difference in the discipline rate. It certainly could be something like discrimination amongst teachers and administrators. It could be differences in behaviors. Those things, we can't answer that here. All we can say is there is a very stark difference in the discipline rates, and it is clearly statistically significant. We can also investigate this with confidence intervals. So reminder, confidence intervals, you have your estimate in the middle, and then for certain variables, there's a symmetric distribution where you get a margin of error on either side. So you have your estimate plus or minus your margin of error. For a one sample proportion, we had p hat would be our estimate plus or minus z alpha over 2 times the standard deviation, and we got this nice confidence interval. For two sample proportions, it'll be similar, p1 hat minus p2 hat. We have our z times the standard deviation, and unfortunately we can't use the pooled one here because in the confidence interval we're not assuming they're equal. We're going to do a confidence interval for the difference, so we can't pool them together, so we have to use the full standard deviation here. All right, let's try that for this example. Here's our data. Let's pull in the numbers for the Black students. So we have p1 hat. That'll end up being 528 over 915. That's about 58%. For the white students, p2 hat, that'll be, let's see, 944 out of 4,004. That's about 24%. We have sample size for the Black students. That's 915. And 2, the sample size for white students is about 4,004. Okay, and then we need a z alpha over 2 for a 95% confidence interval. That's our old friend 1.96. Okay, we got to plug in all this stuff into our formula. So, whoa, it gets a little crazy. But use a calculator, type these things in on a computer or whatever. We get about 34% is the sample difference, the difference between the sample proportions. And then the margin of error is about 0.035. Now, when I look at this, I have to laugh. We can do this in StatCrunch, and I'll show you how to do it in a second. But when I first started teaching almost 20 years ago, we really had to do all this by hand, those poor students. So anyway, if we go to a number line for the discipline rates, we had our white students 23.6%. If we do a margin of error, black students, we do a margin of error. This was the confidence intervals. We did this in a different video. But now we're looking for a confidence interval for the difference in the proportions. So what we're saying is that the difference between these two is 34%. That's what we think, 0.34 in the proportions, or 34%. But we think it could be as high as 37.5% difference, or maybe it could be as low as 30.5%. That's that 34 plus 3.5% or 34 minus 3.5%. Either way, even in this, the minimum we think it could be is a 30% difference between the discipline rates. So that's what I'm saying. There's a clear statistical difference between the discipline rates. So in StatCrunch, it's actually that same menu. We can leave our results and just go options, edit, and instead of a hypothesis test, just click confidence interval, hit compute, and then you get your lower and upper limits for the difference between the proportions. Now, I wanted to find a different example here, and I was wondering that in our Children of Immigrants database, I'll put that link in the description, we had this question where we're wondering about whether there is discrimination in the United States. And we could compare those who are citizens and those who are not citizens. So the statement was there is racial discrimination in economic opportunities in the United States. And there was a strongly agree, neutral, etc. So if we look at the proportion who agree, and we look at the difference between those citizens minus non-citizens, the sample proportion difference, or sorry, I should say the difference in the sample proportions was about 2.9%. The lower limit was negative 1.7%, upper limit 7.6%. So this one is interesting. I wanted to find an example like this where one of them is negative and one of them is positive. So let me go and try to illustrate this here. So we have 2.9%. Now I defined the citizens to be my first sample. So that means they are ahead. So in our sample proportion, more citizens believe there is racial discrimination than non-citizens. Now our confidence interval says it could be as high as 7.6% difference, or it could actually be a negative proportion. So because it could be positive, could be negative, we can't really say there's a difference between these. So if I were writing a conclusion here, I would say, hey, these two populations appear to view racial discrimination in the United States similarly. There doesn't appear to be a difference between citizens and non-citizens, because you can't look at that sample of 2.9%. You have to look at an upper and lower bound. And yeah, it could be as high as 7.6% difference, but it could be negative. It could be that non-citizens think there's more discrimination than citizens. So we cannot say that there's a difference between these. In fact, I did a hypothesis test. If you do a null hypothesis that the proportions are equal, and then an alternative that they're not equal, we didn't have a suspicion one way or the other. When you do the test in StatCrunch, you can see the p-value is fairly high, definitely not less than 0.05. So we wouldn't reject the null hypothesis, meaning we can't say that they're different. All right, that is it for this video on comparing two population proportions. I hope this was interesting and helpful and helped you understand the concept. If you want to see more of these, you can subscribe, hit the bell to get notified. As always, thank you to the Elgin Community College Board of Trustees for approving my sabbatical during the spring 2021 semester. That's how I was able to have the time to produce all these videos and upload them for you. Thank you so much for watching, and I will see you in the next one.